Oh, hi. Um, Welcome back to the continuing lecture series in investment analysis. We have been talking about bond pricing since the past couple of video sessions. And so this is the fourth video, actually, fourth video in uh, the same topic. And so in this video, we're going to be um, working out the this uh, problem. It's also, a slightly different setting, but it's all the same. This this model is already. I just copied that model in the slide and put it here. And you might think this looks quite complicated. No, it isn't. It's not. Actually, as I said, the scenario is always, the same, and it's quite straightforward. Question is always either about the bond price or the yield. So let's take a look at this. And normally I don't like to use this untruncated full verbiage because it's too wordy. Okay, you don't need settlement date. I would just put uppercase T, right? Normally I would because it takes too much uppercase T. Yeah, that's what I put uppercase T. Settlement. It's actually not settlement. I'm sorry, settlement date, so not uppercase T, but time T0. Okay. And maturity date, this is the uppercase T. So it's pretty much like this problem, right? The coupon rate is 6.25%. And this is really, I would say, what they did here, it's really stupid. Why? When you mix up, right, numerical data with text, the text will be useless. The text cannot, the data will become rubbish, right? You cannot, because it is perceived as just text by Excel, right? Excel won't recognize this as numerical data. Excel will recognize it only as text. So I wouldn't do it this way. Normally I would, okay? So what I would do is I would salvage only the, so either I will manually enter, sorry, either I will manually enter 0.0625, since I already set it up as, or I can also do it this way, because you don't have to put coupon here. I will simply, so what am I going to do? I'm going to simply I'm going to go in there and simply delete the text part. Then it's going to become numerical data, right? And I will, instead of, I already typed it in, so it's, okay. For this one, I'll do that. I'll simply, get rid of that. Now it becomes not text but numerical data, and it doesn't really matter. But numbers are left or right aligned. So time maturity, you don't have to verbally explain it. Maturity date, we know that's the maturity, right? Well, this one has actually, this one, the coupon rate is, okay, 4.3, right? Now, it's automatically, it was originally the 4.375, but it rounded it to 2 decimal places. So I went to home ribbon and increased the decimal, show full decimal, and this one was originally 8%. Now, I'm gonna simply, so once you have this data there and as numerical data, you don't need to repeat it. I can directly use it. Okay, but since that was outside the table, use the data inside the table. Now, let me I'll replicate it there. Now, yield to maturity was not originally given. I mean, it was originally given. I mean, you just don't see it in the table. But if you go to the slide, it's given. It's given as just decimal places, 0.02598. But instead of using just decimal places, I turn them all into percentage, right? And so it is common. Yield to maturity is the same thing through and through. It looks like they are all bonds of the same risk class, because different risk class, bonds of different risk class would have a different yield. Now, redemption value, percentage of face value, of course, that means what? Always the redemption value is 100, right? And I already formatted all these cells as dollars. So once I entered 100, and I'm going to copy it over. I'm going to copy that across. So because they all have $100 redemption value. Number of coupon payments per year, of course, semi-annual, all of them, as long as they pay coupons, right? And you might wonder, what are those? What's that in the box? I'm going to get to that later. Now, so we'll find the flat price, which is the same thing as what we did there. So using price command, right? Price, double click. Now first you will need to enter settlement date. This is the settlement date. Maturity date. There you go. Coupon rate. There you go. Enter. Yield. There you go. Redemption. There you go. And then the basis means a frequency. Frequency is semi-annual. So you can either double click on semi-annual, or since we already have number of coupon payments here, I want to use that. And you got 133.04, but that's something. 6.25. Oh, no, 598. Oh, I made a mistake here. 598%. Okay. So the yield to maturity was slightly off because I misentered. So this is the reason when you enter the initial data, initial data has to be entered by you manually. So you have to be very meticulous. You have to be very precise, meticulous. Otherwise, no. Now, so we got flat price, and you don't need to for the rest of them. You can just copy that over, right? Now that's the flat price. For the bond. Something's not right. What went wrong? And you can tell something's not right here already because let me. This one you can tell already. The coupon rate is 8%, which is way higher than yield to mature. But, oh, it's not 8%. Something was. It's not 8%. Actually, that was 8%. Yeah, it was 8%. That was correct. Oh, the yield to maturities are all different. I'm sorry, because in the slide, if you go to the slide, you will find that the yield to maturity is different. So let me. So in the second one, yield to maturity is 3.697. And you have to have and the third case, third example had what was the 10% coupon rate. So here and no, 0.1 because it's already in percent, 10%, and then why so many digits? This is okay. Now it looks, it looks exactly like the result in the slide. So we got now, and you might wonder, but you all understand this is all percentage of the par value, so it's not $137 or $81. It's $1,374.40. It's like, $1,118.20, and this is $810.70, right? And you can tell this will have to be, this will look at the difference between coupon rate and the yield. Coupon rate is much smaller than the yield, and then you ended up with the discount bond. And again, when I thought that they all had the same maturity yield to, they all had the same yield to maturity, I said, well, they must be the bonds of the same class. But no, they must be the bonds of different, class, so they had different yields. Now, from now on, we'll find the dirty price or the invoice price. So to do that, we will have to calculate the accrued interest. So how do you find accrued interest? Of course, first you will have to find out what's the days since the last coupon. And the coupons are usually paid. This is normal, August 15th, February 15th. Those are, like when coupons are paid generally. Now, so we use, coupon base coupon. What is this? Coupon base, right? So then all you need to do is enter settlement date. It's prompting you already, maturity date. And then frequency here too, right? Enter. 0 days have passed. This, because it's 8:15, 0 days have passed. As I said, all numbers will have to be not automatically right aligned, but this one. And you don't have to do it again. You can simply, right? And then in the second example, 90 days have passed since the last coupon payment because it's November, well, today's date is 8:15, so oh, and there is one thing I missed, because when I entered this, there was one more variable that was, and then frequency and then basis. Basis means, if you are using actual dates, or the ordinary 360 days a year or 365 days a year. Okay. Now we use actual, so we enter. Double click on one, and then copy it across. Okay, now we got that. So, and then days in coupon period. How many days has it been since the coupon, last coupon payment? How many days in coupon period? In other words, how many days are separating, one coupon from another? Usually, it's half year, right? Uh, it's just half year is like 184 days, or 182 days. We'll let Excel automatically determine it. Again, the command is coupon days, right? And then also give it what it's asking for, settlement, and then click it in maturity, right? Click it in. And frequency, semi-annual. You can click this, but we have data here, so I'll click that. And then actual, right? So then enter, and we drag it across, okay? So now finding, and again, numbers, numerical data, it should be automatically right aligned, but somehow there must have been some non-numerical data in there, text. That's why this is, or it was entered, the formatting was, not necessarily, for number format, but, some text formatted in text formatting. Now, accrued interest, then think about it. How do you calculate accrued interest? So we know half year rate is this, right? Annual coupon rate is and then half year, you will earn half of that. It's $1,000 times interest rate, a coupon rate, right? Times half, right? Which will give you a coupon payment, and then multiply that by the number of days since the last coupon divided by, I mean, it's already, this dividing by number of days divided by this, that will already give you, this is already half year. So all you need to do is, I'm gonna multiply. Oops, I'm sorry. This one was in. I should. What's going on? Okay, before. So why is it still giving me that red dot? Okay, that's fine. Oh, give me a second. Okay, now that times, face value times 0/184. So in other words, 0 days have passed within 6 months time, right? Because coupon is always semi-annual. Since the last coupon payment, 0 days have passed out of 184 days, which is half year. Now, And obviously, there is no accrued interest, right? So there you go. Now, I I will just paste it across, and then this one. Let's see. So C35, right? Coupon rate times 100, right? So it's actually $1,000 times 92 over 184. 92 days have passed. So then accrued interest is, you might say, oh, $2.19. No, $21.90, and that belongs to the. That belongs to uh, the seller who sold the bond to you, right? So that's the accrued interest. No time at. So um, here's the little bit discrepancy. I don't know what caused this, but 20. Why is it kept? Okay. This number is slightly. Hmm. Um, so a little. There was a little uh, element that I didn't incorporate in here, which is uh, this is actually yeah uh, the fraction of the number of days, right? Fraction of number of days. Um, but what you're getting is not the uh, think about it. Out of $1,000, $1,000 principal, right? If you're paying 6.25% interest, that's annual, right? So actually, we must adjust it by. So nice way of doing this is I want to. Okay, I'll simply divide it by 2, right? Uh, that way, so this is annual coupon, and this is the fraction of the time, the interest as accrued, and you divide it by 2, then that will give you a half year accrued interest. And of course, it won't make any difference because you're multiplying by 0. If you um, drag it across, copy across, then you will find uh, that it was previously that was like 1 year, right? But for half year, uh, this seems correct. So the invoice price is eventually then what? A flat price, or clean price, quoted price, plus accrued interest, and that is the invoice price or dirty price. And you drag it across, okay? Then we find invoice price. So that's $1,374.40. I think that example we did previously. And then this one, $1,129.10. So it's 800. $10.70. Okay. All right. So this is, how you. I deliberately took time. I slowed down so that you can, easily, follow, and you don't, so that you won't get lost. But once you get the hang of it, this can be done in a not 2 seconds, but less than a minute, right? Because all you need to do is input data has to be entered anyway. Input data will be entered, and then basically finding flat price by using the price command, and finding the number of days that have passed using the coupon days formula, coupon days command. You can easily do that. Accrued interest can be found by simply multiplying that annual coupon by the fraction of the days that have passed and dividing it by 2. So there's nothing to it. All right. I'll have to cut the video here. And as for the yield exercise, we're going to have to do it in the next video. So here, stop recording, and I will see you guys in the next video.